Doing something a little different today. Going to just talk about world events. If you guys have any questions that are pertaining to world events and things like that, feel free to ask. I'm going to do my best to keep up with the comments, and we'll go from there. Excuse me. Got a major typhoon. Let me see if I can get you guys a better view here. Major typhoon over in the Western Pacific. I'm sure you guys have heard about it. It's going right towards Taiwan, and it's going to do basically a 90-degree turn here in about 48 hours. Actually, less than that. About 36 hours. It's going to do a 90-degree turn and steer away from Taiwan, which is good. Right now it's a Category 4, but it was a super typhoon there for a minute. Got some things I'm working on here. I'll share with you guys today in this live. Right here, it's a whole stack of just a wide variety of things I'm working on that I'm going to turn into videos here in the next month. That's my goal on some of it. There's quite a bit of material there. Excuse me, I had to get a drink. Some of the things I'm working on. That was a doorbell. Who's here? It's 2 o'clock. I don't know, I just heard the doorbell ring. Okay, some things I'm working on. I'll show you this one here. Solar system. The star that we share, we all call the solar system our home. It's the only thing we've ever known. It's all we'll ever know. But what is this place? You know what I mean? What really is this place? The shape of the Earth. Something else I'm working on right here. Shape of the Earth. This whole stack of things I'm working on. What I'll do is just kind of giving you guys a little behind the scenes things that I do. These are things that I do, and I'll have a thought, an idea, something that I want to work on. So I make little note cards, and they help. They're very helpful, at least to me. And then I'll pertaining to, like for instance, this here. The Earth. It's a big topic, and I don't want to get into the topic today, but it's the shape of the Earth. There's been an ongoing debate, you know, whether the Earth is, in fact, there's a globe up there behind me. I'll get it here in a minute. You know, is the Earth round? Some people are convinced, you know, that it's flat. This is not a flat Earth, round Earth video by any means. But I want to touch on that, and that's something that I'm working on. But I'm nowhere near ready. You know, I've got a lot of things I want to present with my thoughts on it, you know, in my opinion. Not that I'm right, but based off of my observations over the course of many years, what shape I think the Earth is. You know, let's see. Oh, another thing. Here's something else I've been working on. It's that time of year where, you know, speaking of the shape of the Earth, what I'm doing, I'm working on it top back. I don't have it with me. It's a little instrument I made to measure the shadow as we're going to in the equinox. We're going into the equinox in September 22nd, I think. And then from there, as the sun angle goes down to December 21st, you can measure your shadow, and you can watch your shadow grow, you know, through September, October, November, and into December, your shadow will progressively get longer. My shadow the other day, and I keep a journal over here, my shadow the other day, it's because the sun's getting farther and farther deeper in the southern sky, and my shadow's growing. My shadow stopped and went backwards. So it proved to me, and I never shared it with anybody, but it proved to me that the Earth does have a wobble, and it's a noticeable wobble if you measure the shadow. So you have to have a stationary object, but I use a 2-foot piece of round PVC pipe. And I keep it in the same spot, and I drew a circle on the concrete, so I'll know where to, have it sitting in case the wind or whatever blows it over. And then you set I use PVC pipe, and set it there, and then you measure the shadow each day at the same particular time. You got to measure it at solar noon. So I have my journal over here when it's solar noon in my area each day. It's around 12:30, and then for me, and then it goes to 12:29, 12:28, 12:27 as we get further into the fall and winter months. Well, my shadow the other day shrunk. It's been going forward, and then it went backwards. And I'm like, yo, because I measured it at the same time. It's solar noon. And that told me that the Earth's got a wobble. And I detected the wobble by sheer accident. So yeah, we're going to measure and what you can do, you can take your latitude, if you know your latitude. Like my latitude's 33.3, 33.5. Take your latitude, take it times 111.111. 111 right here. 111.111. Your latitude times that number, it will give you a number, and it will be in kilometers. That's how many kilometers you are from the equator. Let me get this up here. This is kind of an old school map. Okay, I'm here. I measure my longitude, which is 33.3 times 111.111. That'll give you your distance from here to the equator in kilometers. You take that number times 0.6214, and that converts it to miles. It's really cool. But basically what I'm getting at is when you're measuring the shadow, when the September solstice is here at the equator, then it goes down another 23.5 degrees, and I'm talking about the sun angle. And then your shadow up here is going to grow longer. And that shows me that the Earth is some sort of a sphere, or it wouldn't do that. That wouldn't even be possible. So you can kind of deduce through some pretty simple techniques, and one of them is by measuring a shadow. You can kind of tell where you're at on the Earth, and you can tell the shape of the Earth. You can detect wobbles in the Earth, and I don't know, it's something. I've done it now. This is my second time doing it. I did it 2 years ago, and 2 years ago I never detected a wobble. This year I definitely detected a wobble, and that wobble was 2 days ago when the shadow went back. It didn't grow consecutively forward. This is one of the many things I'm working on here. Oh, that thing over there, that's I don't know if you can see it. That's flight radar. I keep that up all the time. Keep track of the airplane traffic. It's something I like to do. Your star, our planet. We're going to talk about that. And this is what I was just talking about. See that right there? This is another note card I have. And, with regard to the equator, measuring your shadow, if the Earth were like a flat surface, you couldn't measure that distance. Like I just gave you a little tool to measure your distance from the equator. And that's applicable in both hemispheres, the northern and southern hemisphere. Take your latitude times 111.111. You'd be surprised. Try it. Find out what your latitude is, do that equation, and then go to Google Earth and verify it. And see how close it is. You'd be surprised. I was within 10 miles of my own math compared to Google Earth. Within 10 miles, that's how close it is. But anyway, we're measuring the equinox shadow this year. And I'll give you guys updates. I'm marking it out there on the patio every day. Honestly, I got to be honest. Today I forgot to measure, man. I forgot. I was so bummed out. So I'll do it tomorrow. You better believe it. Something else I'm working on. The old water molecule. The water on Earth. Did you know, or do you care? Did you know or do you care the water molecule, okay? The water molecule. Earth has had, like we're experiencing droughts, we're experiencing floods, and there's an imbalance right now in the water cycle, the way I see it, on our planet. Yeah, we're having droughts here, and we're having extreme floods, believe it or not, in other places too. But at the end of the day, the same amount of water is still here on our planet. That's been here since the dinosaurs walked the earth, And would you believe it if I told you? Would you believe it if I told you that you've shared water, you drank water probably in the last month that a dinosaur drank 100 million years ago? Yeah, you have. So have I. Probably some in this bottle right here. We all have. You've probably at some point in your life shared a water molecule that Jesus himself used. The water cycle is perpetual. It never ends. Water goes from a liquid to a solid to a vapor to clouds. Clouds are water vapor. They hang around in the sky all day long. And then it comes back down in the form of precipitation, rain. It gets filtered through the earth naturally, and then it comes back out in the form of springs, lakes, rivers, and it's reused again over and over and over and over and over. And water on the earth has been reused for millions and millions of years. It's not piped in from another planet. It doesn't come in from space. It goes through a cycle where it goes into the ground, evaporates into the sky, and then it comes back down to the ground. And it's consumed by plants, trees, grass, and animals, birds, and people over and over and over. So back in the dinosaur days, the dinosaurs used the same water that we're using today. And yes, you have shared water with a dinosaur, believe it. More than once. A dinosaur that walked the earth and used the same water that we have today millions of years ago. So yeah, it's true. The Earth's crust. Here's something else I'm working on, the elements in the Earth's crust. These things here are what filter the water that we drink. Like this particular water here, it's filtered by the Earth, but at some point, those water molecules, like I said, were used by creatures of all walks of life. That's what supports life on the planet's this. So all creatures, whether they be, living, walking creatures, land creatures that are, two-legged, four-legged, trees, plants, they've all used the same water over and over and over. And the water on our earth is simply in an imbalance right now. Yeah, we have droughts over here and we have floods over here, but at the end of the day, we still have the same amount of water on the earth. It hasn't changed. It didn't go off into space. It didn't evaporate into Mars's, little atmosphere. It's all right here. It's just in an imbalance. So we're trying to find that golden mean again. There's several things that can cause drought. There's La Nina, El Nino. I think personally that when we mentioned it many times, the Sahara sand that's aloft out in the Atlantic Ocean, it throws off the natural formation of hurricanes and tropical cyclones, and that water can't be moved around to cool the earth like it's supposed to. Hurricanes, like there's a big hurricane, actually it's not real big, it was a super typhoon, but man, is it over there chewing up the heat in the western Pacific, and that's what it's supposed to do. Moving heat, moving water, and so on and so forth. But the crust of the earth is what, I was getting back to this, I kind of get off topic. The crust of the earth is what filters the water that we all drink. We have to have it. And the crust contains 46% oxygen, 27% silicon. Silicon is used in computers, computer chips. It's 8% aluminum, 5% iron, 3% calcium, 2% sodium, 2% potassium, 2% magnesium, and the list goes on. But that's what filters in the earth the water that we that we drink. And then the water, believe it or not, goes, do you think the earth, like, do you think the surface of the earth is free and clear of any cracks that may be on the surface? We see water that occupies 70%. This particular globe's not blue. This is I don't even know where I got this thing at, man. I thought it was kind of cool. But anyway, water covers 70% of the earth. Do you think underneath the water there's cracks that the water seeps through and goes down into the interior of the earth? Wow, thank you, Linda. Yeah. Believe it or not, if you do any studying on that, it sure does. The water seeps down into there's through the crust, then there's the mantle, there's the transition zone between the lower mantle and the upper mantle, and there's what they call a D layer. Then there's an outer core, and this is the one that gets me. This is what gets me. The inner core. The inner core of the earth is a solid, but the outer core of the earth is a liquid. It's really weird. I guess it's so hot that it can't liquefy. I read that somewhere, and I'm still trying to process that one, you know. But yeah, that's what we're told. Oh yeah, here we go. These are notes that I've taken over the last several weeks. I keep it piled right over here. Composition. See, I have a thought. I write it down. Okay, the mantle, the upper mantle, is anywhere from 18 miles to 1,800 miles thick. Water seeps down through the earth, and it goes down into. Can you imagine the reaction when water? Thank you, Andrew. When water collides with magma, and you've got magma and you've got lava, right? Well, when does magma become lava? When it exits the earth. It's magma when it's in the earth. When it's under the crust, it's magma. When it comes out of volcano, then, and only then, it turns into lava. So there's not lava under the earth, there's magma under the earth. There's lava on the surface of the earth that hardens and turns into a crust that we saw, if you were paying attention, in 2018. Where are we at? Right out here. We saw the big island of Hawaii grow. We saw over here in the Canary Islands, we saw one of the Canary Islands grow because the magma exited the crust of the earth and became lava and hardened and became new crust, brand new earth. So we saw the big island grow. I don't know exactly by how much. And the island, La Cambra, what was it? What island over there? It'll come to me here in a minute. But there was some speculation or some talk, you know, that one of the sides of the volcano was going to go into the ocean and cause a tsunami. It's not big enough. It ain't no way. It's not going to happen. Even as big as a Mauna Loa is on the big island, you know, I think that would be hard pressed to create any type of big tsunami, even if part of it went down into the earth. But you can see I'm still working on the lower mantle. I'm just sharing with you guys some things I work on every day. I don't necessarily talk about it every day, but these are some things that I work on every day. I'm working on the lower mantle, working on the D layer, working on the outer core, working on the inner core. And I'm going to put together a video about all this stuff and how it makes sense to me. And thank you, John. How it makes sense to me, and getting back to how I personally think that the Earth is more of a sphere. And I detected a wobble in that sphere myself 2 days ago. If it were flat, see the shadow knows. The shadow knows. And it's a very simple approach to understanding the earth that you live on. The shadow knows, man. So if you could take this bottle and set it outside somewhere where it's got a clear view of the southern sky, and just observe your shadow from September 22nd during the equinox until till December 21st, and watch the shadow every day at solar noon. And it will show you that the sun is indeed going south, the sun angle's changing, the climate changes, that's why we have the 4 seasons. It's all about the sun angle. But you can learn about the sun angle. You can detect wobbles in the earth. If the earth were in a sphere, and this sphere may not be perfectly round, if it were a perfectly round sphere, do you think it would wobble? If it did, you probably wouldn't notice, right? You probably wouldn't even notice. If it were perfectly round, how would you know it's tilted on its axis? I mean, think about it. If it's perfectly round, if you're holding a bowling ball that has no features on it and it has no holes for your fingers, just a round, perfectly round bowling ball, how do you know it's tilted? You know what I mean? So those are questions that I have that I ponder every day, and not every day, but whenever I have something that makes sense, I write it down. At least if it makes sense to me. So we're going to talk about that. These are some things that I'm working on, guys. World news, we're going to talk about Lake Mead and how, in fact, we'll get into Lake Mead right now. Lake Mead is another one of my note cards here. The capacity of Lake Mead it's grown in the last 3 weeks. It's grown by over, I think, 200,000 acre feet. It's unbelievable. So what they're doing at Lake Mead, they're minimizing the outflow opposed to the inflow. So the inflow is increasing, the outflow is decreasing. So simple math will tell you that the capacity at Lake Mead is going to increase instead of decrease. But the only thing, the only drawback, and this is just the way it is, Lake Mead is here, Lake Powell is upstream, So Lake Powell feeds Lake Mead, but Lake Powell is shrinking. So I don't know how long this is going to last, but right now it's great. You're seeing Lake Mead go up, where before, it's just a steady decline. Lake Mead is going up. It's gone up over 3 feet. Over 3 feet in the last 3 weeks. So that's incredible. That's really good. But like I've got here on my note card, Lake Powell, in fact, Lake Powell is behind or in front of Lake Granby. So Lake Granby feeds Lake Powell feeds Lake Mead, and Granby and Powell are both going down. So at least at the moment, maybe that'll change. I don't know. We'll see. But yeah, right now that's phenomenal. Flooding continues in various places around the world. We talk about the drought and things like that. It's an imbalance. There's flooding in Indonesia. There's flooding in Pakistan. We've seen flooding in the Sudan. There's flooding. Where was flooding? I saw the other day. Obviously here in the States, Sierra Leone flooding. There's flooding in the Mississippi River Valley. The Pearl River was at major flood stage for a minute. And from what I understand, I don't know if you guys have heard this or not, from what I understand, Jackson, did you guys hear this? Jackson, Mississippi was without water? What? Yeah, they were without water, going through a flood, and then within 24 hours, they had no drinking water. I'm like, what is going on down there? So if you guys know anything about that, let me know. Where are we at here? It's some things I'm working on. Oh, yeah. Well, I don't know if I want to show this one or not. Lake Powell, Lake Mead. Ah, yes. Some of this stuff I'm going to wait. You guys know what a photon is, right? Photon, and how it takes one photon from the sun 8 minutes to travel from the sun to the earth. Speed of light. It's very simple. We've all heard of it. Speed of light is 186,000 miles per second. That's a constant. That's the speed of light. It doesn't change. And the from what we know, there's nothing that can travel faster than the speed of light. But light does not contain heat. It's vibration. When light comes in contact with, say, sand or a brick wall or a desk or whatever, changes the vibration in the molecules and molecular structure of whatever it's touching. The light itself, the photon, does not carry heat. It carries a vibration. So when it interacts with the Sahara sand that's aloft in the atmosphere, it causes the sand to absorb heat, vibrates. And vibrates at a different frequency. It's hot, it retains heat. So to me, that's why deserts are hot, because of sand. The sand retains heat. So every desert in the world is very hot because of sand. If you took the sand out of the equation, it probably wouldn't be hot. But no, there's an imbalance in our water cycle, and part of it could be, we are in a La Nina. If you guys have ever studied La Nina and El Nino patterns, they do influence the weather patterns of the Earth a lot. I mean, a bunch. And right now we're in a La Nina pattern, which normally when we're in a La Nina setting, which we are, La Nina normally brings more hurricanes. And that's kind of what's not making any sense this year. This year is going to be the first year since 1997. The only other time this has happened was in 1961, where the month of August, and right in the middle of hurricane season, there was not one hurricane in the Atlantic Basin, where the Atlantic Basin is called the MDR, the Main Development Region. The main development region on Earth. And it developed none, in the month of August. So, and it did that in a La Nina season. And La Nina affects the climate and weather patterns. One thing it does do, it also minimizes wind shear, especially at the equator through the tropics. So if there's less wind shear in the tropics, then there's going to be more than likely more tropical storms, hurricanes, and there weren't. So it's kind of like, what's going on here? It didn't make a whole lot of sense. But there are a few right now attempting to form. There's 3 in the Atlantic right now. I don't think they're going to become major storms. And yeah, you're right. RJS world, no hurricanes, none, which is a good thing. We don't want to see big hurricanes make landfall and disrupt people's lifestyle. We don't want to see that, but it is kind of odd not to see hurricanes. That's very telling of something. It's very telling of something going on in your climate, your atmosphere. Something it has changed. The only other, we haven't had a hurricane or tropical storm in the Atlantic Basin since July 3rd. Okay? The only other time this occurred, and it has happened one other time, the only other time we haven't seen a tropical storm, just another statistic, it's kind of, worthless information, but, it means something. July 3rd through the end of August goes clear back to 1941. That was a long time ago. Over 80 years. There was no hurricane activity in the Atlantic Basin from July 3rd to the end of August. So it doesn't look like today there's going to be a hurricane form, at least anytime in the next 24 to 48 hours. There might be one storm or two, but they're going to stay out in the Atlantic Ocean and just remain what they call a fish storm, not going to go towards land, which is good, but they're going to be able to gobble up heat and move some heat away from the equator and try to get the environment balanced out a little bit. We're in an imbalance right now where it's very dry out here in the western United States. We saw some flash flooding up in Las Vegas. We didn't really have a whole lot here in Arizona to speak of. I mean, we had a few moments of monsoon activity. A lot of times the monsoon would come in real fast and you think, wow, we're really going to get maybe an inch or two of rain. Fizzle out. just go away as quick as it started. It's so weird. They got some flooding up in Las Vegas though that did help Lake Mead. All that runoff goes through Lake Las Vegas and then into Lake Mead, depending on where it comes down at. But all the runoff out of Las Vegas went into Lake Mead, so it did help the overall situation at Lake Mead. But it's only temporary because Lake Powell, which feeds Lake Mead, is still going down. Jay Watt, the Earth is a flat, elevated. Hold on. I'm going to try to answer a few of these guys. The Earth is a flat, elevated, in areas plain we live. I call it God's creational, navigational, seasonal time. Okay, you know, you're entitled to your opinion, and I respect that. I do. I respect that. Do this trick though. Go out and measure your if you know your latitude, and you can look up your latitude on Google Earth. Go to Google Earth if you don't know. You can probably do it from your phone. Just ask Siri, say, Siri, what's my latitude, and give the location where you live. Take that number times that number right there. See it? 111.111. That'll give you your distance from the equator in kilometers, okay? And then you take that number times 0.624. I got it written down here somewhere. And that'll convert it to miles if you want to. But that kind of shows you, you know, how far you are from the equator, and it shows you that the Earth might be a sphere-shaped object, you know. Because if it wasn't, you wouldn't have the 4 seasons. That's the way I see it. It's just the way I see it, guys. And, you know, you're entitled to your opinion, and I'm entitled to mine. No big deal. We can all still get along. But we can all certainly have a difference of opinion. That's cool. Hi, Lori Swan. What's up, guys? Hey, Caitlin. I don't come on here a whole lot. I'm going to start coming on here more. Yeah, I heard where Jackson, Mississippi, I would assume, I didn't hear this completely, but I would assume there was a boil order in effect if you had no water, if the water wasn't fit to drink because of the flooding. I would assume that the flooding, I haven't read this, so correct me if I'm wrong, but I'm assuming that the high waters from the Pearl River probably infiltrated the water treatment plant. Am I getting this right? The water treatment plant became contaminated, at least temporarily, until the major flooding went down and they got that drained and refilled with fresh water. That would be my guess. Usually when you're out of water because of flooding, that's why. But I could be wrong. Yeah, we are seeing an increase at Lake Mead, which is so great, you know. Been watching Lake Mead, my goodness, for several months, just every day. And it's just like, wow, you know, there's millions of people that that depend on Lake Mead for a source of water. Millions. I think somewhere in the neighborhood of 30, somewhere, I don't know, 30, 40 million people. It's amazing. From the Lake Mead Reservoir, well, no, I take that back. I stand corrected. There's, I think, 40 million people that depend on the Colorado River for water. There are 12 million or something, I don't know, it's in the millions. I probably got it written down here somewhere. That depend on Lake Mead Reservoir. And not only does it create fresh water for people or provide water for millions of people, it provides energy, electricity to millions of people. So if the water level gets too low, the magic number being 900, roundish, John, thank you. I agree, and I'll leave it at that. I agree. I don't know who this is. Whoops, I'm sorry, Corey, I just missed it. Somebody invited me to go live with them. I will, hang on just a minute. Send me a note, I missed it, or wherever that's at. Sorry, I missed that. Whoop. Yeah, John, thank you for that, and I agree. I'm like I said, I detected a wobble a couple days ago, and the shadow knows. Trust me, set up anything just that can measure a shadow, and don't move it. Leave it there from. You don't have to do it today. you've got until September till the equinox. So start September 22nd. Start measuring the shadow. You'll see it grow. Some days, if you see the shadow retreat instead of consecutively grow, then guess what? You detected a wobble in the Earth. If the Earth was flat, you wouldn't have detected a wobble. I detected it 2 days ago. Yes, my shadow went back. It's not supposed to. Well, it is supposed to do that, but it's rare that you detect it. You know what I mean? And my measurements are right out there on the concrete. I'll show you tomorrow. I'll take a picture of it. The shadow shrunk, so that means that the wobble went. The Earth wobbled because my shadow changed. The shadow knows. The shadow doesn't lie. It can't lie. That's like with light. You know, light is lights and shadows don't lie. They are what they are. So try it. Try measuring the shadow. Do it with your kids. You know, teach them, you know, about the sun angle, how the shadow grows, and your location on the Earth, and how you can learn how far away you are from the center of the Earth. And I believe that the Earth is roundish, just bigger at the equator, obviously. You can measure your distance without going there by simply knowing your latitude, taking that times 111.111. Try it. I don't have my calculator here, or I would do it. Maybe I can do it here. I'll do it and show you. If I can find, do I have a calculator here? I don't know if I do. I should have. Where's it at? Where's my calculator? I don't have one? I'll find it here in a second when I'm not looking for it. I was going to show you how to do it. It's really easy. Hang on, guys. I'm looking for my calculator. I'll find it. Hold on. Give me a moment. Just hang around. Oops. So I don't use this one very much. Yeah, the Nile River is the Nile's flooding. It's just an example of, you know, how out of balance right now the atmosphere is. Okay. Had to Google a calculator. I'll tell you why. Because I'm using my phone. It's got my calculator. Yo, who's that? Thank you, Seth Covington. I appreciate that. It's very kind. Okay, here we go. Here we go. All right. Can you see that? I know it's probably a little bright, right? I'm trying to find an online calculator. Right here. Okay. Yeah. Okay, I'm just double checking my work before I show you guys, right? Okay, here we go. So, I live at the 33, I actually live at the 33.33 latitude. And here we go. 33.3. You guys see that? Yeah, I actually live there. Okay. We're going to take that times. See that? All right, times, here we go. 111.111 equals, you see that? 3,600, just having a little fun here. Something you can teach your kids. 3,699 kilometers from the equator. Okay, but we're going to convert this to miles. So here we go. I'll come up a little closer. There, I know there's glare, sorry. Okay, we're going to take that number times, watch, times 0.6214 equals, what? No, don't do that. Equals, there we go, 2,299 miles. That's how far I am away from the equator, right there. You can also measure the circumference of the Earth. That's why I say it's, you know, it's kind of round when you measure the shadow. You take, let me think here. Oh, okay. Well, there's a whole nother sequence, but I'll share that tomorrow, or in another live. But you can measure, you can take that same number, and you can equate. Thank you, Linda C. You can equate the circumference of the Earth from pole to pole and around the equator, based off of your latitude, your distance from the equator, and you take that number times 360. And then divide it by something else, and that gives you the circumference around the Earth. If it were flat, your shadow and those numbers wouldn't equate. There wouldn't be a mathematical equation. And I'll get it. I got it right here. To measure the circumference of the Earth, you take the number times 360. It's just difficult to do with this calculator. This little calculator is wanting to jump off line on me onto other things. I didn't want it to do that. But yeah, it's just something that I've been working on. The shadow knows. The shadow knows. And it does know. The shadow can only... The ancient Egyptians used the shadow with a obelisk. You know, that's what they used. That's how they calculated time of year. They knew when to plant their crops, you know. And sundials, the old sundial, you know. It's not necessarily the sun. It is the sun, but it's the shadow that it creates. It's very accurate, you know, like with regards to the wobble that I noticed the other day. You know, it told a story. You know, the shadow tells a story every day, and the story is what it is. It doesn't lie. It can't lie. So it's all about the sun. It's all about the sun angle. Everything. That's how crops know to grow, because of the sun angle in relation to the Earth, because the frequency changes, you know. Sun angle's down here, the frequency is less up here. When the sun angle's up here, then things respond differently, you know. Your trees will blossom leaves, and those leaves, you know what leaves are, right? That's how we learned how to make a solar panel, you know, from trees. Leaves are solar panels. They harness sunlight, turn it into energy, and they grow. So we're like, wow, you know, we learned how to fly from watching the birds, you know, the wings and flight. So we learned how to make solar panels by observing our surroundings. It's like, wow, that tree over there is sucking in all that sunlight and turning it into energy. So how can we do the same thing? If we could harness just a fraction, maybe that's what they're up to, I don't know. But if we could harness just a fraction of the solar energy that goes past the Earth on a daily basis, just a fraction, you know, all of our energy needs would be easily met for the lifetime of the star. I mean, it's unbelievable. But more energy goes past the Earth every day in an hour than we'd probably need for 100 years. But we just got to learn how to harness it, and then you know, not disperse it all at one time. You know, you have to use it as needed. But you know, those are challenges that we'll figure out someday. You know, we'll figure out someday. But yeah, it's good to see the solar movement, and the solar panels and wind. You know, I think that's awesome. You know, it should have been done a long time ago. Really, but it's the way it is. So, well, thank you guys for stopping by. I wasn't even expecting to do this, but I thought, you know what, we're gonna do a end of the month video. I wanted to talk about some videos that you guys liked really well, and also I want to thank you guys that are sending in. Again, I think I got it here. Hang on, I'm trying to multitask. Oh yeah, okay, here we go. Cool. I'll use this here. I'm sorry, guys. Yeah. Okay. A lot of you are sending in right here, and this is great because I know you guys have good videos to share, and a lot of times, for whatever reason, they won't attach to email. I get it. I understand. Happens to me. So if you have a large video, or any video that, for that matter, that won't fit in the email, come over here to the homepage of the website. See it right there. You can either go to earthwatchman.com or you can go to MrMBB333.com. Click on this red banner you see right there. See that? Where it says have a large video? Click on that and just follow the prompts. It's very, very easy. You can drag and drop your video into there. Like I got a video today that was like nearly 10 minutes from a young lady. And then please include, if you do happen to send a video, always looking for sky phenomena, please include your first name, the date, and I really love the location. Please don't forget the location. And I know, thank you, Juby Joe. I do know sometimes, you know, you forget. I forget. I understand. I totally get it. But I appreciate everything you guys send in. I wanted to give you guys a shout out that have sent me stuff in Weaver. I'm going to read a few. I got it right over here on a. This is a computer where I retrieved that stuff. In Weaver, Michelle, Steve, Bill, Leia. Leia, I've got your videos. Leia has sent me 2 batches. I'm still working on the first one. Thank you, Leia. Let's see. Belinda, got yours, Belinda. The lightning and thunder. Boy, you had some really close to you. Wow. Misty Flowers, Wesley, Diana, The Reality by Jay, Roosevelt, really cool video. Thank you, Roosevelt. Liza out of Inglewood. I mean, the list is, it goes on and on. Getting a lot of nice videos. And if you guys have a video you'd like to share, go to the homepage of the website. It's easier if you go there. It's easier than trying to attach it to email. There have been times, myself personally, I couldn't attach a 30-second video to email. So go over there and just drag and drop it in there. Include your first name, location, date. I'll take it from there. I'm working on some right now. Those are just a few of the dozens that have been sent in that I'm working on. Really cool lightning that came out of Las Vegas during the active monsoon they had up there, and that's thanks to La Nina. We're in a La Nina weather pattern right now, and we're kind of in between La Nina, El Nino, and they both affect the weather patterns and droughts and floods differently. So right now you can see La Nina's causing flooding in Pakistan. In fact, I got over here, the Sudan, the Nile River is going up. I noticed up here, I have a monitor up here that I literally do. I watch the earth up here all day long, guys. I'll show it to you sometimes. Right up here, right above me. It's a big globe of the earth, real time. The tropical rainforest in Brazil, are you serious? There's smoke billowing out of the center of South America right now. Yeah. Oh, it's a big old forest fire. Who would have thought the tropical rainforests are having wildfires, and a lot of them. There's a huge plume of smoke coming out of South America right now as I do this video. Unbelievable. So yeah, we got to find balance. Measure that shadow. That's a cool little trick, no joke. And you can try it right now. Take your latitude. If you're at the 40-degree north latitude, 50-degree north latitude, 30, take it times 111.111. And then take that number times 0.6214. And that'll convert that number to miles. That's how far you are from the equator of the Earth. And then you take that number times, I think, 360, and that'll give you the circumference around the Earth, I think. Don't quote me on that, but I think it'll give you the circumference. It's over 24,000 miles. I've done it multiple times, but I don't have my math converter with me today. Actually, I do. Aha. I do have. Okay. Yeah, that's right. Okay, that's right. Okay, because I forgot a step. Okay, here we go. Here we go. But we can't do this officially until December 21st. But here you go. I did write it down. You ready for this? All right. How to measure the Earth. How to measure the Earth, the distance around the Earth, using the shadow. And remember, the shadow doesn't lie. The shadow knows. The shadow always knows. Okay. So do what we just talked about. Measure your distance from your location to the equator. Okay, mine is right there. I just showed you on the calculator, 2,290 miles. That's how far I am away from the equator. Okay, take that number times 360. Okay, and I think they use that number assuming that the Earth is pretty close to a 360-degree circular. Well, in my case, that number comes up to right there, 824,400. You're like, wow, that's pretty crazy, right? Well, you take that number, check this out, there's one more step. You take that number and you take that number times the shadow. I know it's getting kind of complicated here, but you take that number, that biggest number, 824,000, times the shadow declination, which in my case, it was almost 34 inches. I measured the length of the shadow on December 21st, but the shadow angle was 33.5. So 824,000 divided by 33.5. Let me see what that comes out to. And that's the circumference of the Earth around the poles, from North Pole to South Pole. Go back to my handy dandy calculator here. Where is my calculator? Oh, there it is. Okay, cool. 824, here we go. 824, 400. And you know what I did? The reason I know how to do it, because I used last year's number. I wrote it down. And the solstice, the December 21st solstice number was 33.5. The angle was 33.5, so I already knew what it was, times 33.5 equals, and that's kilometers, so we got to take that times 0.6214 equals 824,400 times, yeah, times 33.5. This is not the best calculator in the world. It keeps bouncing all over the place. What's going on with this thing? There it is. So you take 824, like in my case, 824,400 divided by the sun angle on December 21st. Not before, not after, on December 21st, on the well, in our winter solstice. And that's the number you get. And that's the the length around the Earth, the circumference of the Earth right there. And you can do it by knowing the shadow. The shadow knows, man. I'm telling you. The shadow knows. So right there, based off of the numbers I have, 2,290 miles from the equator times 360 divided by 33.5, the sun angle on December 21st. I know it's a lot to remember. Gives you the circumference of the Earth. There you go. You can do it at home. It's not hard. I've done it before. I'm doing it again this year. I did it back in, where we at? 22. I did it in 2019. And I measured, I think I may have missed a day or two, you know, but I measured 95% of the time between, and I'm just keeping it real, I didn't measure every single day, because some days it was cloudy, you know. So if it's cloudy, you're not going to get a shadow. Who's that up there? Juby Joe, don't you know? But see, yeah, some days it's cloudy, so you're obviously not going to get a shadow. But if you do get the shadow, just know the shadow knows, man. The shadow doesn't lie. And you can measure the circumference of the Earth based off of that shadow. Pretty cool stuff. Which leads me back to where I started, you know. And this video wasn't about, you know, the big grand debate whether the Earth is flat or round. To me, it's spheroid. And I'll explain why later. Carlos, hey, what's up, Carlos? Based off of the math and the shadow and the behavior of the shadow, if you've ever measured the shadow and you do it consistently, like I haven't done it every single year, but this is my second year, and I've measured it many days. This is the first time I've noticed a wobble, but this is the first time I've noticed a wobble detectable in the shadow measurement this year. I already noticed it, and normally I don't start measuring until September, but this year I'm like, you know what, I'm gonna go ahead and set it out there in August just to get an early start so I don't forget. And I've already got my you want to, it's important. It's important that you measure at the same time every day. So there's a website you can find. I'll put it in my next video. And if you're interested, your location, it will tell you when solar noon is in your location. And mine just happens to be 12:30, 12:29, 12:28. So you want to measure it as close as you can to the same time every day using solar noon. And my solar noon's 12:30. Today it was actually 12:28. So you measure at the same time every day, you can come up with an accurate number that tells you the circumference of the Earth based off of that shadow. Because the shadow knows. Yep. The shadow knows. All right, guys. Well, listen. I don't know what that was. Just heard something vibrate. What was that? Oh. Software update. All these updates. That's what vibrated over there. Software update. Well, thank you guys for stopping by. I just wanted to do a end of the month kind of a roundup. I wanted to show you guys some of the things that I'm working on, that I'll be working on next month. And I'll introduce the measuring of the shadow, and I'll go over it a few more times in case you guys want to try it yourself on how to do the measurements and measure the angle, that angle combined with your distance from the equator divided by this, multiplied by that, will give you the circumference of the Earth. And it's accurate too. I measured, challenged my numbers that I came up with just the other day based off of my 2019 number, because I remembered my 2019 number, because I measured the sun angle every single day from September 21st. Actually, I measured the angle from September 21st to December 21st. And then I followed the sun angle all the way into the end of January. I watched the shadow grow, stop on December 21st, because I was really monitoring the sun angle. And it did stop on December 21st. It didn't go any further south. It stayed there for 3 days, and then it started going back up through Chile into South America towards the equator. So the shadow grows and then the shadow shrinks. But when the shadow can also show you a wobble, which is kind of weird, to be honest. When the shadow retreated on me a couple of days ago, I was like, wow, you know. You know, it just makes you wonder, okay, does it ever, how much does it wobble, you know? And it's not noticeable unless you're actually measuring it. It's not noticeable at all. It's just part of how the world, the mechanics of all this work, you know? That's how it all works. That's how we learn, and I want to learn. I'm eager to learn. There's something. There's more to learn than you can ever absorb in a lifetime. You know, there's just too much to learn. But it's fun to try. You know, I try. Absolutely. There was somebody that wanted to go live, and I'm sorry I missed you. I saw that over here, and I missed it. I'm sorry. I got too many things going at once. But listen, it's been a pleasure. I want to thank each and every one of you for stopping by and spending part of your day with me. I really do appreciate it. And we'll do it again, okay? Because I got to get back to work. So thanks for stopping by. Talk to you guys later. Don't forget, the shadow knows.